Welcome to the second lesson of electric circuits. Now we'll be looking at resistors which are connected in parallel. Now these three equations are very important and you need to know that these apply to parallel circuits or the parallel part of a circuit. 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3, which is the resistance in R1, R2 and R3. V total is V1, which is equal to V2, which is equal to V3. And then your current is split up in a parallel circuit. Therefore, the total current is the current through resistor 1 plus the current through resistor 2 plus the current through resistor 3. So if we look at it this way, we have voltage, which is the same over all three resistors. Then we have current splitting up. So this ammeter would be measuring the total current. Here, your current splits up. One part of the current goes there through these two resistors, and the other part of the current goes through this resistor, measured by this ammeter. So, very important, these three equations. Let's do an example. Calculate the current in this circuit if the resistors are both ohmic in nature. So, this is a parallel circuit. Here is your total voltage, which is the same for R1 and R2. Here goes the current, and now it splits up. One part goes through R2, the other part goes through R1. So, R is V divided by I, Ohm's law. You should know this by now. And then for a parallel circuit, 1 divided by RT gives you 1 over R1 plus 1 over R2. You have R1 given in the question. You have R2 given in the question. So you can calculate RT. You have the total voltage, so you can get to the total current, which is the question. So, step 1 would be to calculate the total resistance of this circuit. Now, very important to check your maths. Resistor 1 is 2 ohm. Resistor 2 is 4 ohm. So, we substitute 2 and 4. Now, we need to add fractions. So, you need to get a common value here. 4 is the higher one, so you multiply 2 by 2 to get to 4, and what you do at the bottom, you should do at the top. 1 times 2 is also 2. So that gives you 2 plus 1 over 4, which is 3 over 4. Now, very important, 1 over RT is 3 over 4, but we don't want 1 over RT. We want the total resistance. So now you have to switch your equations bottom to top. That gives you RT is equal to 4 over 3, which is 1.33 ohms. Step 2 is then to calculate IT. Use your ohmic equation. R is V over I. RT we just calculated, 1.33 ohms. The voltage is given to you in the question, 12 volts divided by I. So then the total current is 12 volts divided by 1.33 ohms. That gives you 9 amperes. The total current is 9 amperes. Example 2. An 18-volt cell is connected to two parallel resistors, 2 ohms and 6 ohms. Calculate the current through each of the ammeters when the switch is open or closed. So first let's look at when the switch is closed. We want the reading on A1, A2 and A3. When the switch is closed, A1 would be measuring the current through resistor 2 ohm. Okay, so we call this the resistor 2 ohm. We then need the volts 2 ohm divided by I to get to the reading on A1. The 2 ohms is given to you, and remember, for a parallel circuit, the total voltage is equal to the voltage over resistor 1 and the voltage over resistor 2. So, the voltage is then also given 18 volts, and this is for the 2 ohm resistor. Therefore, the reading on A1, the current, is 18 divided by 2, which gives you 9 amperes. So, now for ammeter 2. Ammeter 2 measures the current through R2, the 6 ohm resistor. The volt is again the same as the total volt because this is a parallel circuit. So, 6 ohms is given to you in the question, 18 volts given to you in the question. So, the current is then 18 volts divided by 6 ohms, which gives you 3 amperes, the reading on A2. A3. A3 is then the total current. Remember, for a parallel circuit, the total current splits up into the part that goes to R2 and the part that goes to R1. So the total current will then be these two split up currents added together. So the reading on ammeter 3 would be the reading on ammeter 1 plus the reading on ammeter 2, which we just calculated. 9 ampere plus 3 ampere gives you 12 amperes. Now let's look at the situation when the switch is open. As soon as this switch opens, this circuit becomes just this little circuit in series. That whole parallel part is cut out. So, the reading on ammeter 1 would then be 0 amperes because the circuit is now just flowing in this little block. Okay, ammeter 2. We have Ohm's law, R is V over I. The resistance is 6 ohms, given to you in the question. The voltage is 18 volts, given to you in the question. So, the reading on A2 would be 18 divided by 6, which gives you the current as 3 amperes. The reading on ammeter 3 would then be equal to the reading on ammeter 2, since they are measuring the same current flowing in this little block here. We just calculated the reading on ammeter 2, so the reading on ammeter 3 would also be 3 amperes. Thank you.